Hello, this is Mrs. Shank. We're going to start Unit 4 today, and since I couldn't be there in person, I wanted to make you this video so that you could get your notes started. So if you haven't already, go ahead and open up your Unit 4 notes. Now, the very first part of it is really some stuff that is a review from Unit 3. So go ahead and read through the first part of the notes up through Roman numeral 1 and see if you can answer a few questions before you move on and see my answers. So hopefully you realize that the most fundamental concepts of the quantum mechanical model may be modeled with the Bohr model of the atom. That's the one that came right before it. Remember that A, the center of the atom, is the nucleus, which contains the protons and the neutrons. B, electrons are found outside of the nucleus. According to the Bohr model, the electrons orbit in exact circular paths. Remember, Bohr was also called the planetary model because he said electrons are going around the nucleus just like the planets go around the sun. Letter C, Bohr recognized that electrons were found in certain levels of energy. And to go from one level to the next, electrons must have enough energy to go completely there, like from one step to another. So you see this picture here of this ladder. And if you consider the base here, like the floor would be the nucleus, and there's no energy directly in there. But each step here, n equals 1, n equals 2, n equals 3, those are just different levels of energy. So Bohr said that the further away from the nucleus, the higher the energy level was. Now there's a few things to recognize here. First of all, under letter C, to go from one level to the next, electrons must have enough energy to go completely there, like from one step to another. Electrons can't kind of hang out in between these steps. They have to either be on 1, 2, or 3, or 4, etc. The energy levels are not spaced evenly. They get spaced closer together as they are further from the nucleus. You see that 2 and 3 are closer than 1 and 2 were, and as you get up here, they get closer and closer together. Electrons that are further from the nucleus are more likely to escape the atom than electrons that are close to the nucleus. That should kind of make sense because remember in the nucleus you've got the positive protons, and since electrons are negative, they're going to be attracted to protons. But the ones right here, right by the nucleus, they're really attracted to the nucleus. Up here in N6, they're getting pretty far from that nucleus, and they're not going to be quite as pulled in by that positive nucleus. Before we move on to quantum mechanical, we're going to talk about how you could draw a Bohr diagram. There are steps to drawing a Bohr diagram, pretty easy. First, we're going to draw the nucleus in the center and label the number of protons and the number of neutrons. Remember, the proton plus neutron gives you the mass number of an element. Then we're going to draw circles around the nucleus to represent each energy level. We're going to indicate how many electrons go into each level. As we do this, we're going to remember these numbers. The first level takes 2, the second level takes 8, the third level can take 18, and the fourth level may have 32 electrons. So now we're going to start with the example of nitrogen. Before I can complete this Bohr diagram, I have to know some things about nitrogen. Okay, so I had to look up nitrogen on the periodic table. Remember this number up here, 7, is the atomic number of nitrogen. Remember the ape, atomic number equals protons equals electrons. So I know that nitrogen has 7 protons and 7 electrons. Now, in the past, I didn't really let you use this number down here because this is an average. Well, it's the average mass number. We'll go ahead and use the average while we're drawing Bohr diagrams. So we'll say the most common mass number is closest to the average, so that's 14. So usually nitrogen has a mass of 14. If that's the case, I can find neutrons by taking 14 minus 7 because neutrons is mass number minus protons. So in the case of nitrogen, I can say 7 protons, 7 electrons, 7 neutrons. I set this up for you on Google Drawings. If it gets too confusing to use the Google Drawings, feel free to just get a piece of paper out and draw the Bohr diagram. But if you are using Google Drawings, go ahead right now, click on it and go to edit. Okay, so I'm in here to edit. I'm going to go ahead and click in front of protons, and we just said nitrogen has 7 protons. I'm going to go ahead and backspace that to get that up there. Okay, it also had 7 neutrons, so I'm going to go ahead and put 7 in front of neutrons. Again, if you just get frustrated with using the drawings, feel free to do it on paper. It's not the easiest to do on here. Okay, now electrons are also going to be 7. So the first ring is going to have 2. So I'm going to click in there and put 2 by the E minus to show 2 electrons in the first ring. Do you remember how many can go in the second ring? So if you go back and look at the beginning of the notes when we started talking about Bohr diagrams, it says that there can be 8. Now, if there's only a total of 7 electrons, it's not really possible to have 8 in that second ring. So if there's 7 total and there's already 2 in this first ring, hopefully you can guess that you would only have 5 here, because 2 and 5 give you a total of 7 electrons. Okay, so I'm going to go ahead and save and close that now. I'm supposed to do sulfur next, so I'm just going to go ahead and copy nitrogen. And I'm going to go ahead and scroll down, and I'm going to do Control V to paste it into sulfur, and obviously it's going to need some editing. So I'm going to go ahead and edit. Okay, so sulfur is not going to have 7 protons and 7 neutrons, so we need to look that up on the periodic table. Go ahead and look it up right now. So hopefully by looking at your periodic table, you saw that sulfur has an atomic number of 16. That means that there are 16 protons. Sulfur also is going to have 16 neutrons because its mass is averaged to be 32. So if it averages 32 for mass, then it's going to have 32 minus 16 protons is 16 neutrons. And of course, because of the ape, protons is going to be equal to electrons. So I do still have 2 in that first level. This time, because I'm going over this number, I'm going to go ahead and put 8 for electrons. So we definitely have 10 so far. And remember, the third level could hold up to 18. So we're going to go ahead and add that third level. Now, just because the third level can hold 18 doesn't mean it has to. How many do you think it should hold in this case? Okay, so let's go ahead and draw that. To add the third level, I'm going to go up here and I'm going to click on shapes. So I'm going to draw another circle. Didn't get it quite in the right place, so I'm going to move it over. Right now it's colored. I want it to be transparent so that it's not going to cover up everything else. And then this 2, E minus and 8, E minus, those are actually text boxes. So I'm going to click up here on text box, and I'm going to go ahead and draw on another one. And it can take 18, but I don't have 18 left. How many do I have? 2 plus 8 is 10, and then another 6 is going to give me 6 more. So I'm going to go ahead and type in 6 E minus. Oops. And just to say it one more time, if this gets to be too much on a computer, really the most important thing is that you know how to do a Bohr diagram. So just do it on paper. Okay, but here I've got my 6E minus, and I'm going to go ahead and close that. So there's sulfur. Okay, I want you to try the next one by yourself, which is calcium. So try it by yourself first. Okay, so when you're ready to draw it, let me show you, because I put that last circle in, I actually have to order them, and I want to send it to the back. I had done that with those other circles earlier. The reason you do that is because then when you click on here, you're able to get directly into the nucleus. So you're just sending the other circles behind the nucleus, so the nucleus remains up in the front. Okay, so for calcium, you should have put 20 protons. The mass is 40, so 40 minus 20 is 20 neutrons. Neutrons won't always be the same as protons. It just happens to have been for these three examples. But remember, it's protons subtracted from the mass number. Okay, so we do have the 2 and the 8. That makes 10. Remember, the first level can always have up to 2. Second level can always have up to 8. Do you remember what the third level can have up to? 18. And then what about the fourth? 32. So you want to remember those numbers: 2, 8, 18, and 32. So to make 20, I'm going to go with 2, 8, and 10. And there we have calcium. So tomorrow I'll be back and we'll talk about how this all relates to the quantum mechanical model. But before that, just be reminded the main difference between the Bohr model and the QMM. Whereas Bohr said the electrons are an exact circular path around the nucleus, in the current QMM model, electrons are understood to be in certain areas called clouds or orbitals. A chemist named Erwin Schrödinger came up with a mathematical model that estimates the probability of finding an electron in a certain spot. We're going to spend a lot of time over this week talking about those certain spots where electrons might be found. They're called clouds or electron orbitals. We'll go into details tomorrow in class, but for now, go ahead and go back to Google Classroom and do the Bohr model practice.